Consider the polynomial y equals f of x, whose graph is given below. Well, first of all, if this is a polynomial y equals f of x, then it has to have the form a sub n x to the n plus a sub n minus 1 x to the n minus 1, and this will continue until you get the linear term a1x, and finally you'll get a constant term a0. So the first question is, what is the constant term of the polynomial? If you look at this constant term of the polynomial a0, that's the value of the function when x is equal to 0, because when x equals 0, all these terms go away and you're just left with a0. So you can look at this picture right here and say that the constant term to the polynomial here, because it's crossing the y-axis at 2, this constant term in the polynomial has to be 2. Second question is, what's the smallest possible degree of this polynomial? Well, let's start at the bottom. Could this be a linear equation? That is a degree 1 polynomial, and you look at it and say, no, that's not a line, so it can't be a degree 1. Could it be a degree 2 polynomial? Well, that is out because you know that all degree 2 polynomials are quadratics, and if that were the case, the quadratic would either look like this, if it happened to be concave down, or it would look like this if it happened to be concave up. And this graph right here does not have this type of shape. It is not a parabola, so a second degree polynomial is not possible. But this could be a third order polynomial, and the reason for that is it's starting low, comes up to a maximum here, turns around, goes downward, and then back up again. So the smallest possible degree of the polynomial would be a degree 3. We don't get to see what happens out here, down on this part and after, or to the left of -3 and to the right of 2. So it could be a higher order polynomial, but it could also be a degree 3. What is the smallest number of complex zeros of this polynomial? Well, we know to look at the graph right here, we have one real root. That one real root lies between -3 and -2. So the smallest possible number of complex zeros, if this is a third order polynomial, would be there are 2 possible complex zeros to this polynomial.